Ivan Martin is well known in the world of tissue engineering for his work related to bioreactors and the application to bone and cartilage regeneration. Within the field, Ivan is involved in the whole process, from biological to clinical application, where the created tissues are used as grafts for regenerative purposes. Today, we're very pleased to have you here as a keynote speaker at the EUROoCS conference in Milan. Thank you, first of all, very much for your talk that you gave today.
Thank you.
And we are also very happy that you found some time to answer these questions that we have. So, just to start, most research that you have been doing is mostly focused on stuff in the bioreactors, which are a little bit different in the size than we are used to at the organ on chip. How do you think that there's a benefit of your own research to such, devices at a smaller scale?
So I'm convinced that some of the features that we would like to capture in the engineering of our tissues as models, as three-dimensional human organotypic systems can only be captured at a larger scale, at a macroscopic scale, especially if you want to mimic certain trabeculae of the bone, or ultimately if you want to generate and learn how to generate grafts for implantation in patients. But the micro scale, so the organ-on-chip field, the smaller organoids can be used as a somewhat of a reductionist approach to understand how different components interact together. You can deconstruct and reconstruct this environment in a controlled way at a higher throughput with a better level of control. And this is essential to understand then at the microscopic scale how to engineer tissue. Even if there we will always have a somewhat the black box problem that we do not know precisely what happens and who does what at the cellular level.
Yeah, so really these smaller scales are a bit maybe for fundamental approaches, then to sort of understand what's happening at the bigger scale, to sort of summarize it.
Absolutely. And also in our particular field, interested in cartilage and bone, at a smaller scale, it's easier to construct the interaction between the cartilage and the subchondral bone environments, and this enables to address fundamental questions, as you said. So, for example, what is the trigger that initiates osteoarthritis? Is it a signal that is coming from an abnormal molecular process in the bone or in the cartilage? And this whole thing can be much better and controlled, studied in a organ-on-chip system.
Yeah. Okay. Very cool. And you're very involved in using cell grafts as a therapeutic for regenerative medicine, and also in committees of like the mesenchymal stromal cell committee within the International Society for Cell and Gene Therapy. But what are some of the most noticeable hurdles that you still need to overcome to make this technique a bit more widespread within the clinic?
So I'm convinced that if we want to apply regenerative therapies to a broader scale, we need to make them reproducible and robust. And in order to gain this level of control over the process that we activate and the regeneration that we induce, we need to better understand the cellular and molecular processes which are associated. So I think that more fundamental science is necessary in order to make cellular therapies more broadly and more robustly applicable to a larger patient population. Clearly, the clinical trials have to go hand in hand, but the clinical trials have to be somewhat designed in order to understand human biology and not only to see if it works or not.
Yeah, well, I agree. So it really becomes like this, back and forth process, so to say, with the clinic, relying on the biological data, but then also, that the biological data needs to be, validated, so to say, that it's actually then again relevant to the human that we are implementing it.
Yeah. I mean, in the end, the clinical trial is important to understand if a technique or a therapeutic approach is effective, but it's also an experimental model if we want. Yeah. And we should use it as such to test hypotheses and to derive knowledge.
Yeah, and then indeed always later we can start scaling upwards or start thinking about, okay, is this actually applicable with well, as you say, most of the things are experimental and in an academic setting mostly, I think.
Yeah, I mean, sometimes certain health economics persons are a bit skeptic about the adoption of cellular therapies at a larger scale. I think that if we prove effectiveness in a repeatable way, and then the costs can be justified, because what we address is actually a condition of a patient that in society can have and can induce a lot of indirect costs. The problem is whether it can be effective or not, and this is what we have to work on, again, with more fundamental science.
Yeah. And I think indeed that there are a lot of people in society that would benefit a lot from this. So also you are involved as an editor in, amongst others, biomaterials and the Journal of Tissue Engineering. So you probably read a lot of papers or manuscripts within your field that, well, might be of a bit of a different or differing quality, so to say. Like, is there anything that you wished that researchers knew before that they are sending it out to a manuscript out to the editor? They thought, well, this is just easy mistakes that you can easily fix before you send it out. It's to take work out of your hands, basically, as an editor.
As a general recommendation that I would give also to my group and to myself is to try to think whether what I'm going to publish is effectively of impact for the scientific community. So sometimes we're very much driven by the system to publish because we have to graduate as a PhD student, or to show that we can give scientific productivity to apply for the next grant and to receive finances for your group, or because you have to generate the periodic report of your institution. But I think the publication should reflect a contribution which is relevant for the field, which is of interest for the field, so not to dilute the messages and to induce other people to have to read 10 papers to find one that is ultimately relevant for the science. So recommendation is, and again, to myself in first place, to reach a certain level of message and understanding before going to the submission process.
And then I guess it's also then always good to keep in mind what the, targeted audience is for the journal that you pick. So, for example, with tissue engineering, don't show up with, I guess it can also be fundamental, but don't show up with something that's not applicable to.
Yeah. So in this regard, maybe what I could add is that sometimes we and our institutions are somewhat obsessed, if I can say, of having publications in Science or Nature or Cell to be able to have a visibility, also to develop in your career and to apply for a professorship. I think the society journals have their values because they reflect the trend, the perspective, and the direction of a community of scientists in this area. And it should not be underestimated, even if the impact factor of the journal is rather low, as long as what we submit and we publish is a relevant piece of information for the field. And the societies are helping a lot the field to progress, again, thanks to these smaller impact, but extremely relevant publications for the field.
Yeah, and then indeed also these societies, you know the audience, so people are really more, eager to also work with your data, so to say, to further build on the research with that data. So nice. And then, so a bit of a different aspect again. There's always a huge increase of artificial intelligence within science. Where do you see the benefits in your specific field that come from it?
Yeah. What I can see today, I'm convinced will be old-fashioned in 1 year. So the field is growing and developing so quickly that I hardly can imagine where we will be in 3 to 5 years. So unfortunately, I cannot give you an answer to this.
And that's also
I will
fine.
only be happy to be surprised of the opportunities that the field will give us. And I mean opportunities, obviously with challenges and risks that have to be well thought through, but it's huge opportunities that science is receiving through this field.
Yeah, and well, you never know, I guess. Because, well, any collaboration could be around the corner when someone suddenly says, well, I have this nice bit of AI that I can really apply to your research. Yeah, you never know, it can come in 2 days or in 5 years.
Absolutely, absolutely.
And then just to round up, so besides running your research group, I saw that you also own an ice cream shop together with your wife. Is there an overlap within the skills that you need to manage, well, your research group, that you benefit from, that you learned, well, together with your wife in the ice cream shop?
Oh, well, that's quite a challenging question. Yes, at multiple levels. On the one hand, you need creativity to generate a new flavor, and looking around which herbs, for example, you can find in the garden, or which flavors have attracted your attention. And somehow it's like browsing the literature to collect ideas to generate your next experiment. Yeah. So I see this possible similarity. Then with an ice cream, you try to make people happy. And I think, especially with our clinical trials, we're trying to meet the needs of our customers, who are the patients. And if I can dare, the machine that produces ice cream is ultimately a bioreactor.
Yeah.
So it's a cycle which closes up.
Yeah. Oh, that's a very interesting way to look at it. And with that, I would like to thank you for your time. And well, I hope you enjoy the conference.
Thank you very much for your interest, and I appreciate this time.
Right. Thanks.